we have to prove this theorem that angles in the same segment of the circle are equal. So what we do, we will just take three cases of it, right? Where your arc is a minor arc, a semicircular arc, and a major arc, right? So I have drawn here three circles, right? So now let's draw three chords here in three circles, right? Suppose this is AB, right? The chord AB, which we have taken here. Now here we have taken this, exactly in between. That is, it is a diameter, right? And third one is, you can also draw this. And the third one, which we are taking, is here. Okay. Now, center is O. So this is the center. Draw the center. This is O. This is AB chord, right? This is center O, chord AB, right? This is center O, right? And this is AB, right? So we will little shift this chord here. Okay. Now, so what is given here? Very first, we should see like what is given here. Given is a circle C O comma R, right? All are the same circle, that is C O comma R, right? Where O is the center and R is the radius. In which now we will draw here the angles, right? So let's draw the angles. We will take the 2 points here. Like suppose it is C and this is D, right? Now join these points. Okay. Similarly here we can take 2 points C and D, right? Similarly here we can take 2 points C and D, right? Now we will join these points. Now join C A, right? Similarly join C and B. Okay. Now similarly now join B and D and A and D. Okay, right? Now similarly in the next figure, join A and C, C and B. Similarly join B and D and A and D. Now in the third one, join A and C, okay, and BC. Then join BD and AD. Is that clear? Okay, so these are the three cases which we will take here, right? Figure 1, figure 2, okay, and figure 3, right? So now in the circle, in this given circle, CO comma R, what we have here, we have angle ACB and angle ADB, right? You can see there are two angles which are subtended by this arc, by this chord AB, right? In a segment, in the same segment, right? So you can see that this chord is actually dividing the circle into two segments, right? One part is this and other part is this, right? And we are talking about the two angles within the same segment. Is that clear? And that's the reason we have taken these 2 points in the same segment. Are you getting my point? So C and D, we are taken two random points on the circle in the same segment, and now we are just we are see like what are the angles, right? This chord is making at these points. So angle ACB, here it is this. Angle ADB, here it is this, right? Now in the second one, ACB is this, ADB is this. Similarly, the third one, ACB is this and ADB is this, right? So in all these three figures, we have ACB and ADB, right? Okay. These are the two angles. These are the two angles made by arc AB, right? Is that clear? So this is the arc AB, arc AB, arc AB, right? So these are the three arcs here. Arc AB in the same segment. Is that clear? So these two angles are made by arc AB in the same segment, right? And in the same segment. And what is the name of the segment? ACDB. ACDB, right? This is the name of the segment, ACDB. Is that clear? Now what we have to prove? We have to prove here that angle ACB is equal to angle ADB, right? What we have to prove? That angle in the same segment of a circle are equal. We have to prove this, right? So these are the angle within the same segment subtended by the arc AB, and we have to prove that these angles are equal, right? Now we will do some construction here to prove this. Construction, right? Now what is the construction we have done here? That we will join OA and OB in all the figures, right? So let's do that. Join OA and OB. OA. So let me take this point little here. Suppose this is the point, right? Now we will join OA and OB, right? Similarly in the second figure, OA and OB is the same, right? Because we have taken this, the arc is a semicircular arc. And in the third one, it is OA like this and OB. So what we have done, we have joined the ends of the arcs with the center, right? Join OA and OB in all the three figures. Now look at the proof of this theorem. As we know that, we already know this, what? That angle made by an arc at the center of the circle is equal to the twice of angle made by the arc at any point on its remaining part. This we have already done in the previous theorems, right? So write down this quickly. That angle made by an arc at the center of a circle, right? This is equal to what? This is equal to twice of angle made by the arc at any point. Yes or no? At any point on its remaining part. This we have already done, right? In the previous session, right? We have proved this theorem. Remaining part, right? Means angle made by an arc at the center is equal to the twice of the angle made by the arc at any point on its remaining part, right? Okay, so this is the theorem, right? Now what we will do, we will discuss each and every case one by one. Now what is the case one? Case one is, we assume that when arc AB is a minor arc. What kind of arc is this? This is a minor arc shown by the figure 1, right? Is it clear? Shown by the figure 1. This is our case number 1, that this is a minor arc. Is that clear? So look at here, figure 1. So here AB is the minor arc. This is our minor arc, right? And this is the other one is the major arc. Is it clear? Okay. Now, using this theorem, suppose this is equation number 1 or theorem number 1, right? Whatever you want to take. So using 1 here, okay, what we can say, we have angle AOB. This is equal to twice of angle ACB, right? Look at the figure. Angle AOB, this angle, this is the angle subtended by the arc at the center AB. This is the arc and this is the angle subtended at the center by this arc, right? This will be equal to the twice of angle made by this arc at any point on its remaining part. That means this will be equal to twice of angle ACB, right? And this will also equal to the twice of angle ADB. Yes or no? According to the theorem, we have already done this, right? So ये वाला जो angle है, ये इस वाले angle के twice होगा और इस वाले angle के भी twice होगा, right? Are you getting my point, right? So we will write down the same thing, right? So that angle AOB is equal to twice of angle ACB and angle AOB will be equal to twice of angle ADB, right? दोनों के twice होगा, right? Now twice of ACB is equal to twice of ADB. Can we say that from here? Because both are equal to AOB, right? Twice of ACB is also equal to AOB and twice of ADB is also equal to AOB. That means they are equal to each other, right? Okay. So twice of ACB, angle ACB is equal to twice of angle ADB, right? You can write down each equal to angle AOB. Are you getting my point, right? So from here we can say that ACB, angle ACB is equal to angle ADB, right? Is that clear? Means this is the twice of this, right? And twice of this, right? Suppose this angle 1, this is 2, this is 3. So angle 1 is twice of angle 2 as well as twice of angle 3. Getting that? इसका मतलब क्या होगा? 2 and 3 equal हैं एक दूसरे के, right? That means angle 2 and angle 3 are equal to each other. So we have proved that the angles in the same segment of a circle are equal. Is that clear? Right? So we have proved this for the case when the arc AB is a minor arc. Is that clear? Okay, so this we have proved here. Now, case 2. Case 2. What is the case 2? Case 2 we are taking here that when arc AB is a semicircle, right? Means it is a semicircular arc, right? And this is shown by the figure 2. We have already drawn the figure here. You can see the figure, right? So here, if you can see, this is a semicircular arc. AB is the semicircular arc, right? So now in this case, we will prove the same thing again, right? So we know that angle in a semicircle is a right angle. Yes or no? We have already done this theorem earlier in the previous session, right? That the angle in a semicircle is always a right angle. Yes or no? So write down as the angle in a semicircle is a right angle. Means it always measures 90 degree. We have proved this in the last class, right? Okay, that means what? What does it mean? That means angle ACB, this is the angle, so this is the angle in a semicircle, this will be 90 degree. And this is also the angle in the semicircle, so this will also be 90 degree. Means both ACB and ADB is 90 degree, according to the theorem. Are you getting that? So right now, therefore ACB, angle ACB is equal to 90 degree. And angle ADB is equals to 90 degree, right? So both are equal to 90 degree. That means both are equal to each other. Yes or no? Because both are right angles. So we can say that angle ACB is equal to angle ADB, right? So again, we have proved that angle in the same segment of the circle are always equal, right? So we have proved this case number 2 when we have taken that arc AB is a semicircle. Now let's assume the third case. And the third case is when arc AB is a major arc. Okay, this is a bigger one, major arc. This we have shown in the figure number 3. So look at the figure now. So look at here. So here AB is the major arc, means the bigger arc. This one. This is the major arc AB, right? Okay. So here again the theorem number 1 here, which we have written here, that angle made by an arc at a center of a circle is always equal to the twice of the angle made by the arc at any point on its remaining part, right? So can we say that reflex angle AOB? Can we say that reflex angle AOB, this one, this will be equal to twice of angle ACB, this, and also equal to twice of ADB. Is that clear? Right? So this time, what is the angle made by the semicircular arc? This is the reflex angle. क्योंकि यहाँ से यहाँ तक arc है, बड़ा वाला arc है ये. तो यहाँ ये जो angle subtend करेगा center पे, वो एक reflex angle होगा. Is that clear? So this reflex angle AOB is equal to the twice of angle ACB and ADB, right? According to the theorem, right? So again, write it down. So write down that using 1 means the previous theorem, we have reflex angle AOB, this is equal to twice of angle ACB, and reflex angle AOB is equal to twice of angle ADB, right? Again with the same theorem, that angle made by an arc at the center of the circle is always equal to the twice of angle made by the arc at any point in the remaining part. Is that clear? That means what? From these two, can we write that twice of angle ACB is equal to twice of angle ADB? Because both are equal to the same thing. Yes or no? Getting that? So we can write it each equal to reflex angle AOB, right? So from here we can say that this 2 will cancel. Angle ACB is equal to angle ADB, right? So again, now in this third case also, we have proved that these two angles are equal. That means in all the three cases, right? Whether the arc is a minor arc, this is the minor arc, this is the semicircular arc, and this is the major arc. In all the three cases, we have proved that angle ACB is equal to angle ADB. This equal to this equal to this, and this equal to this. Means angles in the same segment of a circle are always equal in measurement. So this is a very important theorem with respect to the questions, right? When you will be solving the question, we will use these theorems again and again. So it is important to understand this theorem and to understand the proof of this theorem also. So sometimes proof also comes in the exams as it is, right? So you should know how to prove this. So I hope you have understood like how to prove this theorem in all the three cases, taking all the three cases that when our arcs are having the different lengths, right? So we have proved that angles in the same which are in the same segment are always equal in measurement. Yes, tell me. Now, look at this theorem number 4. This is very, very important theorem. What it says, if a line segment joining 2 points subtend equal angle at 2 other points lying on the same side of the line segment, then the 4 points are concyclic. Means they are lie on the same circle. So very first we should understand what this theorem says, right? So what do we do to understand this theorem? We will try to draw a figure exactly in the same way as it is given here, right? Okay. So what do we do? So very first write down what is given here. Given is that there is a line segment, right? If there is a line segment, right? So we are writing here a line segment. Suppose AB. AB is a line segment. Right? AB is a line segment. And so let's draw a line segment. Okay. AB is the line segment. Suppose this is the line segment. Okay. Now, what it says, now there are 2 points joining 2 points subtend equal angle at 2 other points lying on the same side of the line segment, right? That means we have 2 points here. Suppose C and D are the 2 points. Okay. C comma D are 2 points. Okay. Lying on the same side. According to the theorem, lying on the same side of line segment AB, right? Okay. So let's draw 2 points. Let just mark the 2 points. So we suppose this is C. This is your AB line segment, right? And suppose this is your D. Okay. Such that they are subtending equal angles at these 2 points, such that they are subtending equal angle. That means if we draw a line, right, and we meet, we join A and C, B and C, right, this and this, and this and this, right? So this line segment at this point, so line segment AB at this point C and line segment AB at the point D, they're making an angle, right? You can see the 2 angles at these points made by this line segment AB. So according to the theorem, it says that they are subtending equal angles. That means angle C and angle D are equal. This is given here, right? Okay. So write down that CD are the 2 points lying on the same side of AB such that angle ACB is equal to angle ADB. So this is given to you, right? That there is a line segment AB and on one side of this line segment. So there are 2 sides of this line segment. When you draw a line segment, there are 2 sides. एक side आपका ये है, एक side आपका ये वाला है, ठीक है? So now in the one side, you are having 2 points. Suppose we have taken 2 points C and D, and the angle subtending by this line at these 2 points means ACB and ADB, they are equal. This much is given, right? So if this is so, now what theorem says? That these 4 points are concyclic. Means these points which you can see here, A, B, C, D, these points will be concyclic. Concyclic means if you draw a circle, all points will lie on the circle. Okay, this you have to prove, right? This much is given that AB is a line segment. There are 2 points C and D on the one side of the line segment, and angles subtended by this line on these 2 points are equal. This much is given. If this is the condition, then these 4 points A, B, C, D are concyclic. Means you can draw a circle which will pass from these 4 points, right? Is it clear? So the points which are lying on the same circle are called concyclic, right? तो ये अब हमें यहाँ पे प्रूव करना है कि ये जो points हैं ये concyclic हैं. Is that clear? So what we have to prove? We have to prove that A, B, C, D, these 4 points lie on the same circle. Is that clear? Lie on the same circle. Now, we need to do a construction here. What is the construction now? The construction is, we will draw a circle. Circle की बात हो रही है यहाँ पे. Draw the circle through 3 non-collinear points. ठीक है? ये non-collinear points हैं. Non-collinear points means which do not lie on the same line, right? From we will draw a circle through 3 non-collinear points. Okay, non-collinear points A, B, and C, right? So what we do? We will draw a circle here which will pass from 3 non-collinear points A, B, C. ठीक है? ऐसा हम कर रहे हैं यहाँ पर. Is that clear? Okay. Now so we have drawn the circle, right? Now we assume here, because it is saying that these 4 points are concyclic. So to prove this, we will first assume that suppose these 4 points are not concyclic. ठीक है? कभी कभी हमें उल्टा assumption लेके चलना पड़ता है प्रूव करने के लिए. So what we are taking in assumption, right, that its converse is true, right? Is that clear? So what we assume that suppose this point is not D, this is suppose D dash. ठीक है? ये D नहीं है, ये D dash है suppose. ठीक है? Suppose this is D dash and we assume that there is some other point D here. ठीक है? यहाँ पे कोई और point है, ये वाला D है. ठीक है? वो D नहीं है, वो ये वाला जो next हमने point बनाया, this is D, right? This is D dash and we have taken one more point, suppose here, which is D, right? And now we will extend this line. Okay, and join this and this, D and B, like this. Okay, is that clear? What we have done? Are you getting this? I will explain you, don't worry. Yeah. So now, what we have done in the proof, we are starting now. If let's assume, suppose D does not lie on the circle. Getting that? What we have assumed that D does not lie on the circle. It is outside the circle, right? हम ये मान के चल रहे हैं, right? Okay, we are assuming that D is not lying on the circle, right? They are not concyclic points, right? Then what will happen? This circle will intersect AD, right? This circle will intersect AD because D is outside the circle. So ये AD कहीं ना कहीं circle को intersect करेगी, right? So this AD will intersect the circle, right? At point the D dash, right? So as you can see here, it is the D dash at which this AD is intersecting the circle, right? Okay, and this AD dash when produced, it can join at D and we can meet D and B, right? So right now, so we have assumed that D does not lie on the circle, then this circle will intersect AD or AD, you can say, or AD produced in D dash, right? Is that clear? Now we have joined D dash and B. As we have already done here, we have joined D dash and B here, right? Okay. Now, look at the figure. ACB and ADB. This is already given equal. ACB and ADB, this is given equal. right? That means this angle is equal to this angle. This already given equal, right? ACB is equal to AD dash B. Why? Why ACB will be equal to AD dash B? This and this will be equal. Why? Because these are the angles in the same segment. And we have just proved this in the previous theorem, that angles in the same segment are equal, right? So by using that theorem, we can say that ACB and ADB are equal. Are you getting my point? Right? So ACB equal to ADB, this is already given in the question. And by the theorem, right, that angles in the same segment are equal, we have find it out that ACB and AD dash B will also be equal. Are you getting my point? Right? So write down that now angle ACB is equal to ADB. This is given, right? And angle ACB is equal to angle AD dash B by the theorem that angles in the same segment. These are the angle in the same segment, which are equal, right? Okay. So what does it mean? ADB is equal to ACB. AD dash B is also equal to ACB. That means what? ADB is equal to AD dash B. इसका मतलब ये दोनों equal है, right? But what does it mean? That this angle and this angle are equal. They are equal. But is that possible? Why? Why it is not possible? Because ADB, ये वाला जो angle है, ADB is an exterior angle of the triangle, of this triangle BD dash D, right? Are you getting my point? So यहाँ पे एक triangle बन रहा है, if you can see here, BD dash D is a triangle, and this ADB is exterior angle of this triangle, and an exterior angle cannot be equal to its interior opposite angle. वो तो दोनों के sum के equal होता है. Are you getting my point? Right? So it can never be equal to the interior opposite angle. One interior angle. Getting that? Okay. So write down. That means what? What does it mean? That ADB and AD dash B, they will be equal only and only if D dash and D are the same point. They are not the different points. Are you getting my point? Right? So when this will happen, this will be true. This is equal to this only when these 2 points are not 2 different points. These are same points. Right? That means D dash and D are coinciding points. That means D lies on the circle passing through ABC, and hence we can say that points A, B, C, D are concyclic. Are you getting right? Okay. So this is true only when D dash coincides with D, right? So these 2 points are not different points. They are same points. So this is true only and only when D dash and D are the same points. They are coinciding points. That means, thus we can say that D lies on the circle, right? Passing through circle, passing through A, B, and C. Therefore, A, B, C, and D are concyclic points, right? So we have proved that A, B, C, and D are concyclic points, right? So what we have done in this question, we have assumed that initially we have assumed that these points are not concyclic, and our results are contradictory, right? And they can be true and only when D dash and D are the same points, right? And that's how we have proved. So many times to prove a theorem, we have to take, right, the other thing as, we assume the other part as true, and then, whatever results you are getting through it, they contradict each other, right? You are getting contradictory results, and that's how you prove. So whatever we have made the assumption is actually wrong, right? It is not possible. So that's why we have proved it. Is that clear? So many times we take help of this type of method of proving a particular theorem or some result. Is that clear? So I hope you have understood like how to, how to prove the theorems, right? So this is also an important theorem of an NCERT book. So I think this is theorem number 9.9, right? So this is your theorem number 9.9 in NCERT book, right? You can see, you can check that. Okay.